Good evening, everyone. I'm extremely happy today because of the name written here at the board, which says surface areas and volumes of combinations of solids. I'm happy because this has always been my favorite chapter during my school days. This chapter belongs to mensuration from class 10, and before starting the chapter, you have to know various concepts of the rectilinear figures like squares, rectangles, triangles, and then also 2D and 3D shapes like circles which you have to know area and circumference of circle like 2 pi r and pi r square. Then also you have to know surface areas and volumes of cube, cuboid, right circular cylinder, right circular cone, sphere, hemisphere. All these have been delved in class 8, 9 and so on. Now in this topic we shall discuss about combinations of solids, which means when one solid combines with another solid, they interact upon each other. You can say they surmount on one solid, like one solid is kept at the top of one solid, another solid, then one solid has been kept inside a solid. So like this combinations. So let's just go step by step into the chapter. Let's just give this as number 1. So first topic would be cone on a cylinder. So let's discuss when a cone is surmounted on a cylinder. Let's just draw the figure. Let us draw a cone first. This is the base. Okay. Now then comes the height of the cone, like this. This is the center of the base. Let's just draw a cylinder like this. This is also the base of the cylinder. Let's just draw the height of the cylinder. It's a right circular cylinder, means the height is perpendicular to its base. So this is center, that's radius. Let us give the radius as r. Since this is r and it has become a rectilinear figure here, this will also be r. So let's just write it. Let r be the radius of both the cone and the right circular cylinder done. Give this a center O dash, different one. And now let us name the height of the cone as h1. Let's just give this as h1, and let us give the name of the height to the cylinder as h2. Let h1 and h2 be the heights of both the figures respectively. Okay. Now a cone has a slant height. That means it has a slope. This one. So there's a name given to this, L. Slant height is always denoted by L. So let us find out the slant height, the value of slant height. You can find out using so just give this name as A, this as B, O. It's a triangle, right angle triangle, so you can use Pythagoras theorem. From triangle ABO, slant height can be found out as this is the hypotenuse, so L square to give you perpendicular square, which is nothing but perpendicular is the height h1 square plus the base square, which is also radius will become diameter, so r square. So what is L? Root over h1 square plus r square. This is the value of slant height. Now let's find out the total surface area of the combination. We have to do this step by step. Therefore, total surface area, we can name this as TSA. So what do you get here? First, curved surface area of the cone, okay, CSA of the cone plus curved surface area of the cylinder, CSA of the cylinder, plus, don't forget one thing, which is the base of the cylinder is already there, which the whole figure is standing, at which the whole figure is standing. So that is nothing but area of the base of the cylinder. So you can write base area of the cylinder. Okay, now we have so many formula for, like, for first it's CSA of the cone, that is curved surface area of the cone. So what is the formula for curved surface area of a cone? We have dealt this in class 9, which is pi RL. Pi times the radius into slant height. Now we have already found out the value of slant height. We can put this in the next step. Plus, what's the value for curved surface area of the cylinder? Curved surface area of the cylinder is nothing but 2 pi RH. 2 pi times the radius into height. So 2 pi RH. Now what is H? It's H2 plus, now base area of the cylinder, that is nothing but the formula for area of circle, which is nothing but pi r square. So pi r square. Let's just put the value of L here. Pi r L is root over h1 square plus r square plus twice pi r h2 plus pi r square. Now you can take thingy common, like pi. You can just take out pi, then radius, one radius from this term, that is r, and just write the whole thingy inside. So root over h1 square plus r square plus twice h2 plus r. That's the derived formula for the total surface area of the combination when a cone is surmounted on a cylinder. Done with this. Next case, we need to find out volume of the combination, total volume of the combination. So therefore, total volume of the combination we can find out by using volume of the cone plus volume of the cylinder. So volume of the cone plus volume of the cylinder. Now what's the formula for volume of a cone? 1 by 3 pi r square h. 1 by 3 times the pi times r into h. 1 by 3 pi r square h1 plus, what's the formula for volume of cylinder? Pi r square h. So pi r square h is nothing but h2 here. We can take thingy common, like pi r square outside. So pi r square h1 by 3 plus h2. That's the derived formula for the total volume of the combination when cone is surmounted on a cylinder. This is how we find out. Just look at this. Just have a glance at the figure and the derived formula. Now we shall be finding out the second one. Number 2, is cone on a hemisphere. Interesting. Let's just draw the figure for this. Let's just draw a cone first. It's like a toy. Looks like a toy. That's the base. Cone is surmounted on a hemisphere. Let's just draw the remaining part of the hemisphere. That's the remaining part of the hemisphere. Okay. The circle is not quite good. Let's just draw it nicely like this. So this is the height of the cone. This is the radius. So let the height be h. There is no height of the sphere, so let it be h. Let this be the radius. So sphere is only one dimension, that is nothing but radius, and the others are diameter, circumference, and so many things. So let's just find out total surface area of the combination. TSA, total surface area of the combination. Okay. At first, we have to find out CSA of the cone plus CSA of the hemisphere. CSA, that is curved surface area of the cone, plus curved surface area of the hemisphere. Okay. What is curved surface area of the cone? That's nothing but pi r L, and you know the value of L for using Pythagoras theorem. Using Pythagoras theorem, from the figure you can say hypotenuse square, which is L square, is equal to perpendicular square, which is h square, plus base square, which is r square. So L would be over h square plus r square. This is how we find out the slant height. Now pi r L plus what is curved surface area of the hemisphere? We know the CSA of the sphere, curved surface of the sphere, which is nothing but total surface of the sphere, because the sphere doesn't have any plane surface. A sphere is always curved and doesn't have any plane surface, so its total surface area would be same as that of the curved surface area. So that is curved surface area of the sphere is nothing but 4 pi r square. So therefore CSA of the hemisphere would be nothing but 4 pi r square by 2, which is 2 cancel, 2 pi r. So just put the value here, 2 pi r square. This is how we find out the curved surface area of the hemisphere. Now we can just put the value of L here, pi r over h square plus r square plus twice pi r square. Just take pi outside and r and 1 r from this side. So that would be pi r common, h square plus r square plus twice r. That's the value for total surface area of the combination. Now let's just find out the total volume. Now you can find out. Next case, just underline this. Total volume of the combination. Okay. So that would be volume of the cone plus volume of the hemisphere HS. What is volume of the cone? 1 by 3 pi r square h. We have done in the previous one. 1 by 3 pi r square h plus volume of the hemisphere. Before that, let's find out volume of sphere. If you have a sphere and have a radius r, volume of sphere will be 4 by 3 pi r cube. 4 by 3 times pi times cube of the radius. The volume of hemisphere will be half of that, half into 4 by 3 pi r cube. 2 2 are 4, so your answer will be 2 by 3 pi r cube. That's the volume of hemisphere. Now let's just put this here, 2 by 3 pi r cube. Now we can take thingy common, like 1 by 3, 1 by 3, just take it outside, 1 by 3. Can we now take out pi? Yes, pi. And r square, and 1 r square from this side. So r square, things will remain h plus, there is 1 2, so twice r, because r square we have taken outside. So here will be twice r. That's the formula for total volume of the combination of thingy. This is how we find out. So we can check the other combinations in the next video. Thank you.